In this lesson, we're going to talk about similar triangles and similar polygons. And we've already talked about congruent triangles, and if you remember in congruent triangles, the angles and the sides of two triangles were congruent. However, in similar triangles, that's not going to be the case. With similar polygons, they're going to have the same shape, but they're going to have a different size. And there are two rules to determine if polygons are similar or not. The first rule is that corresponding angles are congruent. Corresponding angles are congruent. So the angles of one triangle are going to be congruent to all of the angles of the other triangle. The second rule is that corresponding sides are proportional. Corresponding sides are proportional. And that's a little bit different than congruent triangles. In congruent triangles, all of the sides were of one triangle were congruent to all of the sides of the other triangle. And in this case, with similar triangles, they're just going to be proportional. And I'll show you what that means in just a minute. Also with similar polygons and similar triangles, we're going to have a ratio of corresponding sides. And the ratio of the corresponding sides is called the scale factor. And finally, if polygons are similar, then their perimeters are also similar. Perimeters. And if you recall from previous classes, or maybe in middle school, perimeter is talking about the outside of a figure, and more specifically, we're adding together all of the lengths of the outside of a figure, and that would be a perimeter. So let's talk a little bit about what a scale factor is. A scale factor in this case is just going to be a fraction. And if we look at these two triangles, for example, we have a small triangle and we have a large triangle. And so the scale factor between these two is what we're going to figure out. So what they're asking us, note here it says order matters. So it does matter how we set up our ratio. So what I mean by order matters is this says what is the scale factor of triangle ABC to triangle DEF. So they want us to start with triangle ABC, which is the small triangle. So I'm just going to pick a side. It doesn't matter which side you pick. I'm going to do 8, and I'm going to put that over the corresponding side on the large triangle. So the corresponding side on the large triangle is 12. And finally, I just want to reduce that fraction. 8 over 12 is going to reduce down to 2/3. So our scale factor is 2/3. And in the next box, it says what is the scale factor of triangle DEF to triangle ABC. So this time they want us to start with the big triangle and go to the small triangle. So I'm going to follow the same process. Maybe I'll pick a different side. This time I'll start with 15. And the corresponding side on the smaller triangle is 10. And I want to reduce that fraction if I can, and that's going to reduce down to 3 over 2. So notice the only difference that we have from when we started with the small and went to big versus when we went big to small is that the fraction just flipped. Okay? So I also want to look at the perimeter of both of my figures. And remember, perimeter just means to add up all the outside sides. So I've already calculated the perimeter. The perimeter of the small figure, if I add all three sides together, is 32. And the perimeter of the larger figure is 48, if I add all the sides up together. 48. So this question is asking me, what is the ratio of the perimeter of triangle DEF to triangle ABC? So if I start with DEF, that is 48 over 32. And that's going to reduce down to 3/2. And remember what I said up here, that if polygons are similar, then their perimeters are proportional, and that is the case. So look at the sides were proportional, and the scale factor was 3 over 2, and we've got the same scale factor for the perimeters, also 3 over 2. So that is one important characteristic of similar polygons. And another thing that we're going to need to be able to do is write similarity statements. And the symbol for similar is a tilde sign, just like that. Now we wrote congruency statements in our last unit on congruent triangles, and this looks very similar, except we're not going to use a congruent sign, we're going to use a similar sign. So if I'm going to write a similarity statement between this small triangle and the big triangle here, I'm going to say triangle ABC is similar to triangle. Now the second triangle, we have to match up all the angles with the corresponding angles from the first triangle. So if you look up here, angle A has one tick mark, and over here angle D has one tick mark. So we're going to match those up. Angle B and E have 2 tick marks, so E is going to come next, and angle C has 3 tick marks, and angle F has 3 tick marks. So triangle ABC is going to be similar to triangle DEF. So let's take a look at number 1 in the examples. And what they want us to do is list all of the congruent angles and write a proportion that relates the corresponding sides. So the angles are going to be just like we did with congruent angles. So I'm going to look at my similarity statement, and the first angle I see is angle J. So I'm going to say angle J is congruent to, that's the first letter on the first triangle. I'm going to look at the first letter on the second triangle, which is P. So angle J and P match up. Angle K and angle M match up, and angle L and angle N match up, and all 3 of those angles are congruent. But we can't say our sides are congruent because these are not congruent triangles. They are proportional. So I'm going to start with side JK, which is the first 2 letters in my similarity statement, and I'm going to put that over the first 2 letters of the second triangle, which is PM. And I'm going to say that is equal to side JL, which is the first and last letter in our similarity statement, over first and last letter in our second triangle, which is PN. And finally, the last 2 letters of the first triangle is KL over the last 2 letters of the triangle MN. Now if you want to go ahead and pause the video and try number 2, that would be great. But I'm going to go ahead and write down the answers. Angle X is going to be congruent to angle R. Angle Y is going to be congruent to angle Y. Notice that this angle is shared between the small triangle, which is inside of this larger triangle. But both triangles share angle Y, so we are going to say that they're equal to each other, which is also called the reflexive property, if you remember that. And angle Z is going to be congruent to angle S. Now if we're looking at our sides, you should have had XY over RY is equal to XZ over RS, which is equal to YZ over YS. So if you flip this over to the back side, we've got using similar figures to solve for missing measures. There's going to be 2 types of problems. In 4 and 5, they're going to give you the scale factor. Notice in 4, they tell you the scale factor is 2 to 3. So we're going to use that scale factor, except I'm going to convert it to a fraction. And the way we're going to use the scale factor to set this proportion up is, notice that 2 is smaller than 3. So they're starting with the small triangle the small quadrilateral over the big quadrilateral. Since 2 is smaller than 3, we want small over large. So if I look at my small quadrilateral, I have 42. And my large quadrilateral, we're solving for x. So that's how you set up your proportion. And then you can either cross multiply to solve for x, or you can put this in nsolve. And remember, in nsolve on the calculator, you're just going to put that in parentheses exactly like you see it. So 2 over 3 will be equal to 42 over x, and then we need to tell the calculator what variable we're solving for, and in this case it's x, so we're going to put comma x, and when you hit enter, it's going to tell you that the value of x is 63. So I don't expect you guys to solve all of the proportions by hand. I'm mainly concerned that you get this set up correctly, and then you can use nsolve, and I actually put an S in my nsolve there, so let me erase that. So you can go ahead and use nsolve in this class to solve these proportions. So let's look at number 5. They give us the scale factor is 6 over 5. So I'm going to convert that to a fraction. This time I've got the big triangle over the small triangle because 6 is bigger than 5. So we're going to start with our big triangle. Our big triangle this time has the x, so the x has to go on top. Our small triangle has a side 28, so we're going to put 28 on the bottom. If you put that in nsolve and solve it, the calculator is going to spit out x is equal to 33.6. And it's okay to have a decimal in this one. Alright, so numbers 6 and 7, notice that they don't give you the scale factor. So we're going to have to be a little more careful how we set these proportions up. But they give us a similarity statement, so we're going to know which side matches up with which side from the small triangle to the big triangle. Okay, so they want us to find the value of x. So x is right here on side AB. So I'm going to, basically what this is going to look like before I start this, is I'm going to have a fraction equal to a fraction. And so I'm going to start wherever my x is. Here's my x, and it's on side AB, so I'm going to put my x on the top side of that fraction. Then I'm going to look at my similarity statement, and AB is the first 2 letters of the similarity statement on the first triangle, and DE is the first 2 letters on the smaller triangle. So I need to match AB up with DE, and DE, looking at the triangle, is 25. Alright, so now I want to go back to the big triangle, and the only other side they give me here is 28. So I'm going to put 28 on top, and that is side BC. Looking at the statement, BC is the last 2 letters, which is going to match the last 2 letters here, which is EF, and EF is 20. So you're going to put that in nsolve, and the calculator is going to tell you that x is equal to 35. Now, a couple important things that could throw you off here is that since we started with the big triangle on top of this fraction, we also have to start with the big triangle over here on the second fraction. So basically, your top numbers from your fractions need to come from the same triangle, and the bottom numbers need to come also from the same triangle. Okay? If you mix those up, you're going to get the problem wrong. Alright, so let's go ahead and take a look at another example with number 7. And this is not a triangle, but everything works the same way. So they still want us to find the value of x. So I'm going to find my x, which is right here. I'm going to have a fraction equal to a fraction, so let me go ahead and set that up. Let me go ahead and put my x there. X is on side RS. Looking at my similarity statement, RS matches up with XZ, and that's YZ, and YZ is 32. So we're going to put x over 32. I'm going to come back to my big shape, and the only other side they give me here is a 75, so that's going to go on top of my second fraction. That is side PS. Looking up here, PS is the first and last letter, so we're going to look at the first and last letter over here, which is WZ, and WZ is 40. So that should be the way you set up your proportion. And to solve that, go ahead and put it in nsolve on your calculator, and you're going to get x is equal to 60. Alright, 2 more examples, and this time it looks a little more complicated because now we don't just have one x, we have x's in 2 different places. But it's okay, we're still going to solve this the same way. So I'm going to have a fraction equal to a fraction. And let's just start with, this time I'm going to start with the smaller triangle, and I'm just going to pick either side. It doesn't matter which side you start with. The first thing I see is x plus 6. So I'm going to put x plus 6 on the top. That is side dx. If I look at my key here, my similarity statement, dx is the last 2 letters. So I'm going to match that up with the last 2 letters over here, which is gm, and gm is 36. So let's put 36 on the bottom. Now going back to the small triangle, the other side that I have is x plus 3. That is side kx. Looking up here, kx matches up with AG, and AG is 32. So you're going to type this into nsolve exactly the way you see it here, and the calculator is going to tell you that x is equal to 21. Alright, let's look at our last problem. I have two more similar triangles. This time I have an x on both of my triangles, so it doesn't really matter where you start. So I'm just going to pick the large triangle, and I'm going to write down my variable, which is 4x minus 1, and that is side ly. Ly up here matches, that's the last two letters, that's going to match the last two letters over here, which is hk, and hk is x plus 5. And we're going to set that equal to whatever the other side is that they give you. In this case, it's 25 over, let's see what that matches up with. This is side TL. TL is the first and last letter. So we're going to look at the first and last letter over here, which is CK. And, sorry, that's not CK. That is CK. And I think I misspoke there. Side 25 is TL. TL is the first two letters in our similarity statement. Our first two letters over here are CH, and CH is equal to 10. So that's how our proportion should look. Now you can either cross multiply, or I would suggest putting this in nsolve to save you a lot of time. And the calculator is going to tell you that